Welcome to AI Frontiers, where we explore the latest cutting-edge research in artificial intelligence. In today's episode, we're synthesizing 16 influential papers that collectively showcase the current direction and future potential of the field. These papers represent diverse approaches, methodologies, and applications, but together they paint a fascinating picture of where AI research stands today and where it might be heading. As we analyze these papers, we'll identify key research themes, examine groundbreaking results, explore common methodologies, and take deep dives into particularly influential works. Through this exploration, we'll gain a comprehensive understanding of the current state of AI research and the exciting possibilities it presents for the future. Join us as we begin our journey through the current trends in AI research. Synthesizing 16 significant papers in computer science artificial intelligence. Computer science artificial intelligence represents the core discipline within computer science, focused on developing computational systems capable of performing tasks that typically require human intelligence. The evolution of AI has been marked by several pivotal developments. Early AI systems relied heavily on symbolic approaches, using explicit rules and logic to solve problems. The field experienced a significant shift with the rise of machine learning, which enabled systems to learn patterns from data rather than following pre-programmed rules. The emergence of deep learning, particularly since the early 2010s, has further revolutionized the field, enabling unprecedented advances in areas like image recognition, natural language processing, and game playing. Today, we're witnessing another transformation with the rise of foundation models, large-scale AI systems trained on vast amounts of data that can be adapted to a wide range of tasks. These models, exemplified by large language models like GPT and multimodal systems that can process both text and images, have demonstrated surprising capabilities and have opened new research directions in areas like alignment, interpretability, and multi-agent systems. This broad field now addresses fundamental questions about machine learning, reasoning, perception, and decision-making, with applications spanning virtually every sector of society, from healthcare and transportation to entertainment and scientific discovery. Our first major research theme focuses on large language models, their applications, and architectural improvements. Recent research shows LLMs extending well beyond general text processing into highly specialized scientific domains. For example, Wang and colleagues demonstrate LLM applications in chemical synthesis planning, showing how these models can navigate the complex space of retrosynthesis planning. This application illustrates how LLMs can accelerate research and discovery in chemistry and materials science. In another significant paper, Xu and colleagues propose a framework called DialogueReason, which enhances reasoning capabilities in LLMs by structuring the reasoning process as a dialogue between multiple agents rather than a monologue. This approach represents an innovative way to improve problem solving in LLMs, particularly for complex questions that benefit from multiple perspectives and iterative refinement. The prominence of LLM research in these papers reflects the broader trend in AI toward leveraging these powerful foundation models for an increasingly diverse range of applications. Researchers are finding creative ways to adapt and enhance these models to address specific challenges, from scientific research to improved reasoning capabilities, demonstrating the versatility and potential of large language models across numerous domains. Our second major research theme explores agent-based systems and multi-agent frameworks. This research direction focuses on developing AI systems that can act autonomously in environments, often in collaboration with other agents, to achieve goals. One paper introduces a control plane as a tool design pattern for scaling agentic AI systems, addressing challenges in tool orchestration and system management. This work acknowledges the increasing complexity of AI agents that need to coordinate multiple tools and capabilities, proposing architectural patterns to manage this complexity effectively. Another paper examines architectural precedents for general agents using large language models, identifying common patterns across different research traditions. This synthesis of approaches from cognitive science, classical AI, and modern neural methods provides valuable insights into the components necessary for building more general and capable AI agents. Liu and colleagues present a multi-agent reinforcement learning approach for cooperative sensing in emergency rescue scenarios. This work demonstrates how heterogeneous agents, including humans, aerial vehicles, and ground vehicles, can effectively collaborate in complex and dynamic environments. This theme reflects a shift in AI research from developing models that excel at specific tasks toward creating systems that can operate autonomously in complex environments, often in collaboration with humans and other AI systems. Our third research theme examines cybersecurity applications of AI, particularly automated penetration testing. As AI systems become more capable, researchers are exploring how these technologies can be applied to identify and address security vulnerabilities in digital systems. One notable paper by Dai and colleagues introduces RefPentester, a knowledge-informed, self-reflective penetration testing framework powered by large language models. This system assists human operators in identifying vulnerabilities in target systems and learns from previous failed operations to improve its strategies. The framework successfully revealed credentials on a hack-the-box machine, outperforming the baseline GPT-4o model by a significant margin. By combining large language models with structured knowledge and self-reflection mechanisms, RefPentester represents an innovative approach to automated security testing. This research direction highlights the dual nature of AI in cybersecurity, both as a potential vulnerability if AI systems themselves have security flaws, and as a powerful tool for enhancing security. By developing AI systems that can automatically identify and help address security issues, researchers are contributing to more robust digital infrastructure in an increasingly connected world, potentially transforming how organizations approach cybersecurity challenges. Our fourth research theme encompasses several related areas: trustworthy AI, explainability, personalization, and embodied intelligence. As AI systems become more complex and widespread, the need for transparency, interpretability, and alignment with human values has become increasingly important. One paper surveys recent advancements in explainable AI, highlighting the connection between explainability and meta-reasoning in autonomous systems. This work emphasizes the cross-disciplinary nature of trustworthiness, involving both technological solutions and alignment with societal standards. Another paper surveys foundation models for personalized federated intelligence, proposing a vision of artificial personalized intelligence that adapts powerful models to meet specific user needs while maintaining privacy and efficiency. This approach integrates federated learning with foundation models to enable personalized deployment at the edge. Several papers also emphasize the importance of embodied intelligence and causal reasoning for advancing toward more general AI capabilities. One paper argues that embodied artificial intelligence, which involves systems with physical presence and real-time interaction with the environment, is key to unblocking generalized artificial intelligence. Another paper proposes a trajectory prediction framework for autonomous driving that leverages causal inference to enhance predictive robustness and generalization, moving beyond pattern recognition to understand the causal relationships governing traffic behavior. Now let's examine some of the most groundbreaking results presented across these research papers. Dai and colleagues introduced RefPentester, a knowledge-informed, self-reflective penetration testing framework that successfully revealed credentials on a hack-the-box machine, outperforming the baseline GPT-4o model by 16.7%. This substantial improvement highlights the value of combining multiple approaches, large language models, structured knowledge, and self-reflection to address complex security testing tasks. Xu and colleagues demonstrated that dialogue-based reasoning can significantly improve problem-solving in large language models. Their DialogueReason paradigm structures reasoning as a dialogue between multiple perspectives rather than a traditional monologue, leading to enhanced performance on complex problems. Tunsi and colleagues introduced a novel formulation of causal knowledge graphs that extends traditional knowledge graphs with formal causal semantics. Applied to medical datasets, their approach successfully reproduced known adverse drug reactions with high precision while identifying previously undocumented significant candidate adverse effects. Johansson and colleagues demonstrated the emergence of arbitrarily applicable relational responding within the non-axiomatic reasoning system. Finally, Sun and colleagues introduced conflict-aware task merging, a training-free approach for resolving conflicts in model merging that achieved average accuracy improvements of up to 2.5% over state-of-the-art methods without requiring additional training. Across these research papers, we can identify several common methodologies that represent the current approaches to AI research. Large language model prompting and fine-tuning is prevalent across many papers, leveraging pre-trained models like GPT-4 or open-source alternatives and adapting them to specific tasks through carefully crafted prompts or additional training. This approach harnesses extensive knowledge embedded in pre-trained models to address specific tasks without requiring training from scratch, offering flexibility across different domains. However, it also has limitations, including potential hallucinations and high computational costs. Reinforcement learning from human feedback is another common methodology, training models using feedback from human evaluators to align model behavior with human preferences and values. Multi-agent frameworks enable coordination and collaboration between AI systems, allowing them to address complex tasks through cooperative action. Causal reasoning approaches move beyond correlation to understand underlying mechanisms, potentially improving generalization and robustness. Finally, knowledge-enhanced approaches integrate structured knowledge with neural methods, combining the strengths of symbolic and statistical AI. These methodologies each have their strengths and limitations, but together they represent the diverse toolkit that researchers are employing to advance artificial intelligence across various domains and applications. Let's take a deeper look at one of the most innovative papers in our collection, RefPentester by Dai and colleagues. This knowledge-informed, self-reflective penetration testing framework represents a significant advancement in automated security testing. The system combines the language understanding capabilities of large language models with structured knowledge about cybersecurity vulnerabilities and attack vectors. What makes RefPentester particularly innovative is its self-reflection mechanism, which enables the system to learn from previous failed operations and adapt its strategies accordingly. When an initial attempt to identify a vulnerability fails, the system analyzes the failure, identifies potential reasons for the unsuccessful attempt, and adjusts its approach in subsequent iterations. This capacity for iterative improvement addresses a key limitation of existing automated security testing approaches, which often struggle to adapt when initial attempts fail. In practical tests, RefPentester successfully revealed credentials on a hack-the-box machine, outperforming the baseline GPT-4o model by 16.7%. This substantial improvement demonstrates the value of combining multiple AI techniques, large language models, structured knowledge representation, and self-reflection to address complex real-world challenges in cybersecurity. As digital systems become increasingly complex and widespread, automated tools like RefPentester could significantly enhance our ability to identify and address security vulnerabilities. Another groundbreaking paper worth examining in detail is the DialogueReason framework by Xu and colleagues. This innovative approach enhances reasoning capabilities in large language models by structuring the reasoning process as a dialogue between multiple perspectives rather than a traditional monologue. The researchers found that this dialogue-based approach outperforms traditional monologue reasoning, particularly on compound questions that require integrating multiple pieces of information or considering diverse viewpoints. By structuring reasoning as a dialogue, the system can explore different aspects of a problem, challenge initial assumptions, and iteratively refine its understanding. This finding challenges conventional wisdom about how reasoning should be implemented in AI systems. Traditional approaches often focus on single-stream reasoning, where a model works through a problem in a linear fashion. The success of dialogue-based reasoning suggests that incorporating multiple viewpoints and structured interactions can lead to more robust and diverse reasoning processes, potentially addressing some of the limitations of current AI reasoning capabilities. This result has implications beyond the specific implementation described in the paper. It suggests that mimicking human collaborative problem-solving, where different perspectives interact and build on each other, might be a valuable approach for enhancing AI reasoning more generally, influencing the design of future AI systems across various domains. The third paper we'll examine in depth is Toonsey and colleagues' work on causal knowledge graphs. This research introduces a novel formulation that extends traditional knowledge graphs with formal causal semantics. While traditional knowledge graphs capture relationships between entities, they typically don't distinguish between correlational and causal relationships. By extending these graphs with causal semantics, the researchers created a more powerful framework for understanding and reasoning about cause and effect relationships in complex domains. When applied to medical datasets, their approach successfully reproduced known adverse drug reactions with high precision while also identifying previously undocumented significant candidate adverse effects. This integration of causal reasoning with knowledge graphs provides a generalizable, knowledge-driven framework for scalable causal inference in healthcare. The successful application of this approach to adverse drug effect identification demonstrates its practical value. The ability to not only confirm known adverse reactions, but also identify potential new ones could significantly impact drug safety monitoring and personalized medicine. This result suggests that causal knowledge graphs could become an important tool for healthcare researchers and practitioners, potentially improving patient outcomes by identifying adverse effects earlier and with greater accuracy. Beyond healthcare, this approach has potential applications in any domain where understanding causal relationships is crucial, from economics to climate science. Looking toward the future, several promising directions emerge from these research papers. First, the integration of symbolic reasoning with neural approaches appears to be a fruitful avenue for developing more robust AI systems. By combining the logical rigor and interpretability of symbolic methods with the flexibility and pattern recognition capabilities of neural networks, researchers may be able to address some of the current limitations of both approaches. Second, scaling multi-agent frameworks to address increasingly complex real-world problems represents another promising direction. As these papers demonstrate, multi-agent systems can effectively coordinate to solve problems that would be difficult for single agents, suggesting potential applications in areas ranging from emergency response to collaborative scientific research. Third, advancing causal understanding to improve generalization and robustness remains a critical challenge. Several papers highlight the importance of moving beyond correlation to understand causal mechanisms, potentially leading to AI systems that can better generalize to new situations and demonstrate more robust performance in changing environments. Fourth, developing more efficient personalization techniques that preserve privacy will be essential as AI becomes more integrated into daily life. Finally, enhancing explainability and alignment as AI systems become more powerful will be crucial for ensuring that these technologies serve human values and can be effectively understood and controlled by their users. This synthesis was created using Anthropic's Claude 3.7 Sonnet 2025-019 model, with text-to-speech synthesis performed using OpenAI's TTS technology. Visual elements were generated using Stable Diffusion image generation. The content underwent review by human experts for accuracy and coherence. While we've made every effort to provide a comprehensive overview of these research papers, we acknowledge that potential oversights may exist in the synthesis. The AI models used to create this content have their own limitations and biases that may affect the presentation and interpretation of the research. Additionally, our selection and emphasis of certain papers and themes necessarily reflects subjective judgments about their importance and relevance. We've attempted to present a balanced view of the current state of AI research based on these 16 papers, but this represents just a snapshot of a vast and rapidly evolving field. Different selections of papers might highlight different themes and directions. Despite these limitations, we believe this synthesis provides valuable insights into current trends in AI research and the exciting possibilities that lie ahead. We hope you've enjoyed this exploration of current trends in AI research. Subscribe to our channel for weekly research syntheses and analysis that keep you informed about the latest developments in artificial intelligence. Join our community of AI researchers, practitioners, and enthusiasts to discuss these findings and their implications. Receive notifications about upcoming deep dives into emerging AI topics, from reinforcement learning to multimodal foundation models. Share your thoughts and engage with other viewers in the comments section below. Help us improve by suggesting topics for future research syntheses. We value your input and aim to cover the areas of AI research that most interest our audience. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses RxIV.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by RxIV.org.